All right, guys, moving on to number 9. This is actually a really good example of section 5.3 when we did the definite integrals. Okay, and that was really just evaluating things before we learn those rules of integration, just based on a picture, or in this case, it's based on numbers that we've given you. This kind of like combines what we did on that quiz on the top and the bottom of the quiz. We have a picture, but there's also, we don't know the function, we just know the numbers. So they've told us that the shaded region A has an area of 1.5. And since it's below the x-axis, in our integral, we would know that the integral from 0 to 2 is that of, whatever this function happens to be. I guess we're calling it f. F of x is actually negative 1.5 because it's below the x-axis. And then they tell us that the integral from 0 to 6 of the entire thing, of the whole function, from here all the way to here, this whole integral evaluates to 3.5. So that's good to keep in mind. All right, let's answer letter A, we already did. This is going to be negative 1.5 because even though this area is 1.5, it's below the curve, negative. All right, well, 2 to 6. This one we have to think about a little bit, right? We know that from 0 to 6 is 3.5, so I'm actually going to write it out. If I went from 0 to 2 of f of x dx plus from 2 to 6 of f of x dx, I would get from 0 to 6 of f of x dx. All right, so let's plug in the numbers we know. We just said this was negative 1.5. This is the one we're looking for, so I'm just going to leave it blank for now. And we know it equals 3.5, because that was the other piece of information they gave us. So negative 1.45 plus something is 3.5. To get it, I'm just going to add 1.5 to this side, and that's just going to give us, 4 or 5, right? So this number has to be 5, which says this integral has to be 5. All right, so now we know this area is 5, and this area is 1.5, but it's below the x-axis, so that's 1.5. So letter C tells us to do something first. It tells us to take the absolute value of our function first. And taking an absolute value of a function takes anything negative and makes it positive. So rather than being below the x-axis, this 1.5 will now be above the x-axis. So our area from 0 to 6 is going to be 1.5 plus 5, or 6.5. All right, the next one. Forget about that whole above the x-axis thing. That's gone away now because we've taken away those absolute value signs. And now we're just saying negative 2 times f of x. Constants are great because just like derivatives, we can actually pull them through the integral symbol. So this is the same thing as negative 2, 0 to 2 of f of x dx. All right, so negative 2 of 0 to 2 of f of x dx. We already know that this, we came up with that way back in the beginning, was negative 1.5. So negative 2 times negative 1.5 is positive 3. All right. Number E, letter E. Oh. Okay, we're allowed to separate. The sum and difference rule says we can separate this. So we can do the integral from 0 to 6 of 2 plus the integral from 0 to 6 of f of x dx, right? So let's do this separately. This one we already know, 0 to 6. They gave us right up there. That's 3.5. So we're going to be adding 3.5. Well, 2, if you give me a second, is actually like we have it aligned on our graph at 2. And we're going along, and we want the area under this curve, right? Well, the area under this curve will be 2, the height of that rectangle, times the bottom of the rectangle, which is 6, and that's just going to be 12. If you don't like visualizing that, which is totally fine, there was that little rule that we had learned, which was said if you were going from A to B of a constant, that was actually equal to the constant times B minus A. And that works here too. That would be the constant 2 times 6 minus 0, or 2 times 6. Anyway, we add these two together, and we actually get 15.5. All right, average value. We haven't talked about that in a while. We did talk about it. Average value was the formula for it. Let me just kind of rewrite it down here. The average value formula said that the average value would equal 1 over b minus a times the integral from a to b of f of x dx. That's the formula. So, for us, the average value over 0 to 6 would say, just using the formula, 1 over 6 minus 0, the integral from 0 to 6 of f of x dx. Well, that's 1/6 times the integral from 0 to 6, which they told us is 3.5. And off the top of my head, I don't know what 3.5 divided by 6 is, but that would be the answer. All right, moving on. Number 10, find f of 4 if the integral from 0 to x of f of t dt is this value. Okay, so this is kind of backwards. They've given us the integral, and now they want us to find, they want us to plug 4 into basically what's the derivative, you know? This is like big f of x. It's the antiderivative. So what we want to do here is we want to take the derivative of this. We want to take the derivative of x cosine pi x. It's a product rule. So we want d dx of x cosine pi x. I'm going to treat this like my u and this like my v. So it's u times the derivative of v, which is negative sine of pi x times pi. That's an x right there. Plus v cosine of pi x times the derivative of u, which is just 1. Okay, and now we're going to plug 4 in for all of our x's, because this will be f of x. Right, that's what this really is, f of x. Let's plug it in. So we've got negative 4 sine of, negative 4, I'm sorry, there's a pi right here too. Negative 4 pi sine of 4x plus cosine of 4 pi. And I don't mean pi there, I meant 4 pi. I'm sorry. Okay, let me start again. I made a mistake. So it is, I've got a negative, I've got an x, which now is 4, and I've got a pi, so negative 4 pi sine of 4 times pi, 4 pi, plus cosine of 4 times pi. All right, if you remember your unit circles, you know the sine of any whole pi is actually 0, so this is 0, plus the cosine of 2 pi is 1, so the cosine of 4 pi is also 1, so this is actually just 1. All right, number 11. Here we know that big F of x is equal to the integral from 1 to x of f of t dt. And f of t, they have given us another whole crazy integral. And they want the derivative of f prime of 2. Okay, so they want the derivative of this. And we have learned that the derivative of f, so f prime of x, is equal to the derivative of this, 1 over x of f of t dt, which, by the fundamental theorem, the d dx and this cancel out, and we plug that x right back in, right? And we said that that is just going to be f of x. All right, so f of x, or f of t they've given me, is this integral right here. So if we want to go ahead and find this derivative, I think I'm going to need a little bit more space. So I'm going to pick this up on the next video.